Good morning, students. As we discussed earlier in the videos, we discussed about the production automated process flow lines. In that, we discussed about the different types of the flow lines, what we are going to use, okay, and so on and so forth. Now, we are going to discuss about a computer aided process planning. Actually, this is the chapter 4 in a model 2, and this is very important chapter for the industry point of view. One thing you remember that whenever we are going to design any part and we are going for the manufacturing process, but we don't have any plannings when we are going to perform any manufacturing activities. If you don't have any plannings or anything else, it's very difficult for us to manage the manufacturing activities. We have a design, we have a machineries to manufacture the product, but if we don't have any process plan, what are the type of the materials we required, what are the operations we are going to perform, and what are the things we require to perform all the operations, and these are the many questions which we are going to collect before we are going to start any manufacturing activities. Now here, this computer aided process planning, what it means. In generally, when we are going to say, the process planning is a connectivity between the design and manufacturing activities in the organizations. Now, these are the some contents which we are going to discuss today. Okay, in introduction about the computer aided process plan, what are the general steps which is involved for preparing this process plan, and in that there is two types of process plans we are going to discuss. One is variant approach, and also this one we call it as retrieval approach, and the second one is a generative computer aided process planning. Then finally we are going to discuss about what are the benefits which we are going to get when we are going to use a computer aided process planning. Okay, now we are going to discuss about this. The first thing, a general manufacturing activity which we are going to manufacture a product from raw material into a finished product. The first one, in the design we have to first create a product design, what type of product we are going to manufacture, and based on that we are going to do the process plan. In that process plan, as earlier I said, that what are the things we require, what are the machinery we required, what are the operations we are going to perform, what are the cutting tools we required, how many people we required, what type of skilled labor we required for particular operations to perform. Like that, all the process and machining knowledge we required to prepare this process planning. Then after preparing this process planning, then plan for the operations. And after a route sheet is prepared, then verify the route sheet whether the plan is correct or wrong. If it is correct, then go ahead for the scheduling. Now we have to schedule what are the, for example, in a machine shop we are going to perform lathe operation, milling operation, and shaping operations. Now in that classroom we already scheduled that first we are going to perform a lathe operation. Different types of the operations we are going to perform, like plane turning, knurling, thread cutting, taper turning, okay, step turning. Like that, many operations we are going to perform. Based on that, first which one we are performing, second which one, third which one, fourth which one, because before we have to prepare a plane turning operation, then we are going to perform step turning, then we go for knurling operation, then we go for taper turning operation. All these operations are come into our, who is going to operate that machines, he should know, and also we have to schedule what are the steps we are going to perform, and it is a scheduling knowledge, based on the scheduling knowledge. And finally we have to start manufacturing of that particular product. Clear? Then before that, what is process planning? Here the process planning is nothing but the translation of design information into process steps and instructions to efficient and effective manufacturing. Now here the translating a design information, just now I told that in a machine shop what are the operations we are going to perform to make particular type of the product, and process steps, which one we have to perform first, second, third, and so on and so forth to complete the product. As new age manufacturing process are involving a computer aided process planning, it helps in simplifying, efficiently carrying out a conventional process planning and optimizing use of resources. Now here, previous some 10 or 20 years back, what happened, they manually, there's some process planners, they are going to sit and they have to prepare all these process plannings while we are going to convert from raw material into finished product. All the activities manually they are performing. Now what happened, now in the market we are going to get a software that is like CAPP, as we call it, CAPP softwares are available, and by using these softwares, if you have a design of a particular product, directly we are going to get all the process plans directly from that software, and based on that we are going to make the process plans. And also here the conventional process planning, as a person is sitting and preparing a process plan and optimizing the use of resources, is very difficult and it is very time consuming activity to make that process plans. And the third one is a detailed set of instructions, engineering drawings, specifications, parts and materials list, and etc. Here the resources like that, it's a engineering drawings we require, specification, parts, material list, and what are the things we require to convert the raw material into final product. Now the CAPP, a development of a process plan, and also we call it as a route sheet. See, whenever you are going to visit in the organization, you just go there and see that there is some route sheets. Always they are going to place on the notice boards or any boards. In that they are going to give what is the process plan in that particular shop floor is going on. Is in the following up, there are two types of approach, as I already stated, that is a variant or retrieval computer aided process planning approach, and second one is generative computer aided process planning approach. For example, if any design changes or changes in the cost estimations, say when we are going to conventionally preparing these process plans, if the design changes, is very difficult for us to change the process plan. If any machine breakdown occurs, at that moment how we are going to change the process plan again, and we have to find the alternative solutions. For that it is very time consuming, and interaction among various functions of an organization and dynamic changes. If any organization we are going to change machines or change operations or anything, if you are going to change, it's very difficult for conventional process planning, because we have to change entire process which we are going to carry out to convert from raw material to final product. But when we are going to use these two approaches, then we can reduce the time for preparing the process plan. And these are the some of the general steps which is involved to prepare a computer aided process plan. The first one is design input. That means whatever the drawing we prepared, that is the design inputs, and what are the materials we are going to use to manufacture that product, what type of the product, and what is the type of the material we have to prepare. Then we have to go for process selection. In a machine shop, I already told that what are the process we are going to perform to make that final product. In that we are going to perform many operations, that is a turning operation, milling operations, shaping operations. Okay, what type of the process we have to perform. Then we go for sequencing. What is the sequence, which one if we are performing 3 machines we are going to use, and we have to first decide what sequence, what machine we are going to use first to make that product. Then machine and tool selection. Then it comes, that is a what type of machine we require and what are the cutting tools we require to make that product. Then intermediate surface determinations. That means here in a manufacturing there is a 3 important parameters. One, size, second one is shape, and third one is the surface properties. Because if you are going, if the customer is not willing to see the surface finish, he is directly rejecting the components. Because nowadays what happen, if you are using a CNC and ANC machines, in that we are going to get in a micron level, that is a finishing of a products. Then after selecting the machine, now we have to select the fixtures. The fixtures are very very important for machining operations, because the fixture is nothing but it is a work holding device. Work holding means it's on a work table. When I am going to keep the material, only just it is a free. Now I have to hold that work material rigidly on the work table. That's why we require a fixture. That's why we have to select the fixture selections. Then go for the machining parameter selections. Whatever the type of the machine we are going to use, what parameter we require, whether it may be a feed, whether it may be a depth of cut, whether it may be a surface property, whether it may be a distance traveled by the cutting tool from one place to another place, to make a final and good products. Then finally we have to go for cost and time estimation, for what operation, what material, how much time we required, and how much cost we have to invest for making the product. Then finally prepare the plans. And these are some general steps which is involved in a process planning. And come to the next part, that is a retrieval computer aided system, process planning system. In this is very very important. Nowadays all the industries maximum they are using this one. Because what happened here, we are going to group, we are using a group technology. That means a similar type of the part families we are going to group and place that details in the database. And here from the part families, by the grouping the parts, second one is develop a standard process plan, then retrieve and modify the standard plan for the new parts. For example, now a new part design, now the part is designed, then we have to give the code for that particular part, and that part details are stored in our part family files in a particular code. Now then that part family, it will hold that database of that particular part. Then search the part family file for a GT code number. Then the third step is we have to search the code of that particular component which is already saved in our database file. Then we have to retrieve the standard process plan, and we can directly retrieve from that file, just like copying that material or data details of the product and pasting in a required process planning software. Otherwise, now search the part family GT code number. If it is there, then select the standard process plan file and retrieve it. If you have these two in our database, then we have to retrieve that process plan directly from the part family file. Then edit an existing plan to write new plan. If any small changes in the product in the particular part, we can edit it, or existing plan, whatever the existing plan is already there, you have to edit it or write a new plan for that particular product. Then process plan formatter, we have to generate that process plan within a computer, what I said. And finally we have to publish the process plan, that is we call as a root sheet. That means that root sheet it will give an entire operations and entire process we are going to carry out to convert from raw material into finished products. And these are the three steps majorly we have to follow in a retrieval or variant approach. That means a part family and by grouping parts, then develop a standard process plan, then retrieve it and modify it. That means identify the similar type of the parts. Now, so there are some examples which are already given, that a similar prismatic part requiring similar milling operations. Now you just see that here there are some of the operations are similar, like a drilling, okay, milling operation, face milling operations, okay. It is a box type of the product. Only if you have this type of the product details in your database, then directly extract it, and whatever the product model is there, now you just remove these parts, remove the positioning of the drilling and place in another drilling process, because you are going to save whatever the part which is already you have in your database. Then if it is a prism like structure, that means we also called as a prismatic part is nothing but it is a prism like structures or prism like parts. Now extract this, okay, then you have to do some end milling operations, then prepare this and the part is prepared. And now second example, a dissimilar part requiring similar machining operations, hole drilling, surface milling. Say that it is a different one, this one is different and this one is different. Okay, for that reason we have to identify what type of the material we require and what type of the process plan we have to prepare. Then identical design parts requiring completely different manufacturing process. These are the parts are identical, but we are using a different manufacturing processes. And by using this variant cap approach, what are the advantages we are going to follow? Processing and evaluation of completed activities and managerial issues are done in an efficient manner. This means we can easily identify the what type of a product we are going to manufacture, whether it is already existing in our database, and lead to reduction of time and labor requirement. Because whenever a conventional process planning method, if I am going to use a machine and a person, he has to plan the activities, and also we are going to reduce the time required to make the process plans, because every time a new design is available, then every time if you are going to do that process plan repeatedly, it will take more time, because some of the information is already available in our database. Second, the structuring manufacturing knowledge of the process plan to company needs to standardized procedures, then reduce the development and hardware cost and shorter development time. Because when I'm going to already have all the data or details of the product in my database, then it's very easy to develop the part, and it is very time consuming. Time consumption is very less. Like that, there is always some advantages, there is some disadvantages are there. In that it is difficult to maintain the consistency during the editing. Say that if the data is available, now I'm going to take the data and now start editing. Say that when I'm going to write the program from starting to end is very easy, but when I'm going to edit it, we have to carefully do that operations, because if small mistakes, it will entire process plan will be failed. That's why it is more difficult. Next, the proper accommodation of various combination of attributes such as material geometry, size, precision, quality, alternate processing sequence, and machine loading among other factors are difficult. Say that if I have a data or a details of the product in my database, if the material is different, and the geometry is different, and the size of the product is different, precision is different, quality is different. It's very difficult to identify those things which is already saved in my database. Okay, if I'm going to write that program from the starting to end, then it's very easy for me to make a final process plan, and it's very easy. Then we have to take care of all these parameters and factors very carefully when I'm going to copy the part data or part details from the database. The quality of the final process plan largely depends upon the knowledge and experience of the process plan. Whoever is going to take the part process plan from the database, he must have a knowledge of a process plan. These are the major disadvantages of variant process approach. Then comes the generative computer aided process planning system. In this, as we discussed in that previous, the plans are generated by means of decision logic, formulas, technologies and algorithms which we are going to use. The main aim is to convert the part from raw material to finished product. This is also same. Input to the system includes the description of the part in the form of part code number. Okay, in the previous we are going to take the part design, then we are going to find whether it is present in our database or not, then extract it and modify it and prepare it. But in the generative computer process planning, for each and every part designs, we have to prepare a separate process plan. That means we have to get the knowledge of all these manufacturing facilities. What are the machine tools we require, cutting tools, jigs, materials, all these things we have to consider and prepare a process plan by using this algorithms, formulas and decision logic technologies. Based on that, we have to prepare the process plan for each and every product. There is no any copying the details of the part from any database, because we are not going to store any data or any details of the product in our database. For each and every product, we have to create one process plan. And in this generative, there is a two approaches we are going to use. One is the geometry based coding system, another one is knowledge based. In a geometry based, all the geometric features for all the process such as related surfaces, features, dimensions, location of the features are defined by geometry based coding system. That means, see, for example, if I am going to take this as a part, this is the part I am going to select. In this, what are the features are there based on the advanced phases. Now just says this is the one phase, another phase, third phase, 4, 5, 6 phases are there. In that, we have to identify the features which is present in the particular phase. Now you just see that there is a 4 drill holes, or 4 holes are drilled on the phase, advanced phase. That means these are the features you should know. What are the type of the material we require, cutting tools are required, and what are the operations we are going to perform, and the geometric information of each and every drill you should remember. Then the level of detail is much greater in generative compared to the variant, because in that we are going to copying the things which is already there. But here, every time we have to get the details of each and every features which is present on the face of the product. This is the geometry based, because we are going to consider the geometry of the part. Then knowledge based. In that, process knowledge in the form of decision logic, data use for matching the part geometry requirement and manufacturing capabilities. Today's last bit of this chapter is one is benefits of CAP. If we are going to use a computer aided process planning, what are the benefits which we are going to get? The first one is and everyone you should go through the first word or keyword which is in the sentence. Reduced process planning and production lead time. These two are very important. Reduce a lead time, faster response. That lead time is nothing but whatever the product manufacturing the time. We already discussed in the manufacturing lead times, in that when the raw material enters into the machine and after completing all the operations in that machine and it comes out from the entire operation completed, after that a finished product, whatever the time it is required, that is we call as a manufacturing lead time. That means if I am going to take 20 minutes 20 seconds, if I am manufacturing that product which in 18 seconds, now I am going to save 2 seconds. That means if I am going to use a CAPP, I am going to reduce 2 seconds to manufacture this product. In a one day, if I am manufacturing 1000 products, if I am going to save 2 seconds from one product, that means 2000 seconds I am going to save. Instead of manufacturing 1000, if I am using this one, I am going to manufacture 11,000 products per day. That means 100 products, 1000 products I am additionally manufacturing. That means reduce the process planning. A production lead time increases. Faster response to emerging changes in the product. If any changes be done in the product, we can easily shift. That is we call as a flexible, as we already discussed in the flexible automations. And by using the CAPP, a greater process plan accuracy and consistency are there. And in that, up-to-date information in a central database, as already I discussed, all the data are stored in the database. Whenever we require, we can retrieve it. Improve the cost estimating procedures and fewer calculation errors. That means here estimating procedure is very important, because whenever we are going to do any manufacturing activity, the cost is important. Cost estimation is very important, because each and every activity it includes some cost. Okay, by using this CAPP, we are going to estimate the costing for each and every operations, products and different types of the parts, whatever we are going to use for manufacturing. And also the errors are very less, because a standard process plan is available for us, and it is a more complete and detailed process plan. And here by using a CAPP, we can get a improved production scheduling and capacity utilization. Whatever the type of the materials we are going to use and what are the type of the machineries we have, whatever the capacity of the organization, we can improve. In a plant capacity, we solve many problems. Okay, instead of if I have a 10 machines, then I am going to manufacture 1000 products if I am using a conventional process planning method. If I am using a computer process planning method, then I am able to manufacture 15,000 products in a day. That is a improve in a utilization capacity of the organizations. Then we can make the scheduling of a production operations. And finally, improve the ability to introduce new manufacturing technology and rapidly update process plan to utilize the improved technology. See, whenever I am going to use a improved technology, that means if I am using a manual machining operations, instead of that one, if I am upgrading to the CNC machines, and these process plan we can shift easily, and also fastly we can change it, upgrade it. And these are the some of the benefits we are going to get by using a CAPP. Okay, up to this the CAPP we discussed, and in the next video I am going to explain a different concept of these CAPP systems. Thank you.